grade friends. This is Mandy Combe, your curriculum math consultant again this week for your remote lessons. Today we're going to do things a little bit different. You're not going to see me work out problems. I'm actually going to use the PowerPoints that we have, and we're going to go and go through those as we look at the instruction for this week. So right now what you will need is your colorful pages for lesson 10. You'll need page 92, 93, 94, and 95. And then after the lesson, you're actually going to work through your practice and problem solving book. And for your grade level, those pages are red. It's just all red. And those pages are 103 through 106. So we're going to be doing the introduction lesson and the modeled and guided lesson, instruction lesson today. We're going to talk about place value and multiplying, which really helps us kind of multiply easier. So let's dive right in. I'm going to share my screen with you guys. And it's just taking a couple of minutes. There we go. Okay, so this would be the same thing that you're seeing on top of your page, on page 92 of your instruction book. You have these books, and it has a story problem or a real life problem, a real world problem that goes along with it. And we're going to think about this problem. We're going to solve this problem. So we know at the top, it always wants us to make sense of the problems we're given. And that is so important, guys, because we have to look at exactly what is being asked of us and the question that they want us to answer. Often with our real world problems, our textual problems, we have a question to answer, and sometimes that's not our solution that we find when we do the operation we're doing with our numbers. So we're going to look at what the problem is about. We're going to think about what we're trying to figure out and what information is important to take away from this. So we're going to think about ways that we could solve this. And I really just want you to look at your model. Really try not to look at the stuff below the model, just to really think about the model. So there are 4 stacks of books on the table. Each stack has 20 books. How many books are there in all? So let's think about what the problem is all about. And this is a good time that you can talk with that instructional partner of yours and just have a conversation about what the problem is all about. So we really want to talk about that we have books that someone has nicely stacked up in sets of 20, and that we have 20 of those sets. So they've taken a big total and they've put them out into equal groups. And what are we trying to figure out? We're trying to figure out how many books they have in all. Maybe somebody gave them these books and they need to make sure they have enough room for them. So we're really looking at and trying to figure out, help them figure out, and help them solve how many books there are in all. So we're looking for a total number, not a piece of or a part of, but a total number, a total amount. And then we got to look at what information is important. Well, it's definitely important to know how many stacks of books there are. That's really, really important. And then it's really important to know how many is in each stack. But where those stacks are located, that they're sitting up on a table, is probably not that important. Just the stacks of how many of the stacks of books you have, and then how many are in each stack. And then what's most important is what are they wanting us to do with all that? And that last question, how many books are there in all, tells us what they're wanting us to do with it. They're wanting us to tell them the total number that they have of all these books. So I am now going to give you a couple of minutes to stop, think about, and see if you can solve this problem. When you are done solving it, you can discuss it with your instructional partner. And I would like you to see if there is another way that you can solve it. So let's go ahead and get started on that. And I'm just going to slide away for a minute and then I'll come back. Okay, my third grade friends, it takes a minute for my camera to come back on. If we take a look at this problem that we have all kinds of different ways that we could solve this. And I really hate that we can't have a discussion together about this. It makes teaching very difficult and very different for me because I really like it when my students have conversations about math. So what we can first do is you may want to first make sure that there are 20 in each set. But the set that they have up here, one of the things that they've given us as a clue to a possible way that we can solve it is they've divided that first set into tens. And so we know if each set has 20 in it, how many sets of 10 would that be then? If we have 4 sets of 20, how many sets of 10 that would be? So you're right. If you would take that and divide it into smaller groups, into sets of 10, we would have 8 sets of 10. Or we would have the 4 sets of 20. So how might we solve this? There's lots of different ways. We could count by tens. And guys, do we remember how many times we're going to count by tens? We're going to count by 8 times. And I'm going to try to put my cursor on here. My cursor is really big because often I can't find it. So I made it really big. And it helps when we're doing this. So there's 10 here and 10 here. We know 10 and 10 is 20. There's 10 here, which is 30. 10 here, that's 40. 10 here, 50. 10 here, 60. 10 here, 70. 10 here, 80. So we know that counting by tens, we can get to the correct amount. And ladies and gentlemen, that is basically what y'all have learned before as repeated addition. Is taking the equal amount that is in each group and adding it up. Adding the amount of each group up over and over and over, the number of groups you have. So we added it 8 times. We added 10 8 times to get 80. We could also do the same thing, but do it with 20. So we could add 20 4 times. We could say 20 books here plus 20 books here. Guys, can you tell me what that solution would be? If you said 40, that is correct. 20 books here, which would be 60, and 20 books here, which would be 80 also. Notice that we did come up with the same answer doing it both different ways. And that is also repeated addition. There were 4 stacks of 20, and we added 20 4 times. Another way that we could do this is we could actually write an equation and do multiplication with this. So I'm going to let you take a couple of seconds, a couple of minutes to think about what a multiplication sentence would possibly look like and that would represent this. Go ahead and get started on that. Excuse me. I'm looking to see if there's a way I can write. So let's talk about what this could look like as a multiplication sentence. So if we have, well, let me step back for just a second. What model does our books look like? If we were to talk about a model that we could draw to show multiplication, what model does our books look like? If you said an array, you are correct. So we have 20 going down, and we have 4 going across. So this definitely could be an array. And when we look at that, we know how to make a multiplication sentence using an array. So the multiplication sentence would look like 4 times 10. 4 sets of books times, I'm sorry, not 10, times 20. Because we have 20 sets of books here. So just like an array. So we're going to make sure that we multiply both of those. Now that we know that, we can write our solution. We know that they had 4 stacks of books with 20 in each stack, so 4 times 20 equals, and the product of 4 times 20 is going to be 80. So there are 80 books in all. And I'm going to let y'all just kind of sink that in, think about that, maybe finish up your equation before we go on for just a second. Okay, folks, I just want to throw a question at you and let's see what you guys think. It's along these same lines. I want you to think about 2 times 4 times 10. And if you need to, you can write that on your paper. And 8 times 10. So if we were to look at that, I'm going to try 2 times 4 times 10 and 8 times 10. Are those the same? Are those equal to each other? Take a second and talk to your instructional partner or your friend about that. You might want to solve them. That would help. So if we look at the top one, 2 times 4 is 8. And 8 times 10 is 80. Well, once we multiply the 2 times 4, we can see that it is the same. They both become 8 times 10. So really, guys, when we have really big numbers, it is okay to break apart the numbers to make it easier to multiply. Anytime you need to do that, go right ahead. I know that I often do that if I'm at Home Depot and I'm buying wood and I want to see approximately how much it would cost or approximately how much I need. I may round a number up so that I am multiplying by, a single digit instead of lots of digits and decimals. So let's take a look at the questions. There we go. This is some questions that you guys can use to talk about this, to talk about the lesson, to talk about the instruction that's going on with your instructional partner. Often, I like that first one. I'm not sure how to find the answer because often, sometimes we're just not sure how to get started. And so drawing a picture, writing it in a different way, all those types are ways that to get started. Sometimes I have to write down the information that's in the problem. I might have written 4 stacks of books, 20 books in each stack equals total number of books. Sometimes I have to do that myself in order to figure out and make it organized to figure out what we're doing. The strategy I used to find their answer was, now there's a part 2 that should be part of this statement is, and I chose that strategy because often we know how to do a strategy or how to do a procedure, but we need to make sure that we know why we chose that one. Do you agree with me? Why or why not? Why did you choose that strategy? So that one kind of goes along with that second one, like I said. So these are the questions that we have underneath our picture on our page. How many books are in each stack? Well, class, how many books did we decide were in each stack? We decided that there are 20. There are 20 in each stack. How many 10s are in 20? So we would divide 20 up into 10s to make a new, basically new stacks. How many sets of 10 would we have? We would have 2 sets of 10 because there are 2 10s in 20. 10 plus 10 is 20, or 10 times 2 is 20. How many groups of 2 10s are there in all the stacks? What are they really asking here? How many groups of 2 10s are there in all the stacks? So how many groups of what, class, are they looking for? How many groups of 10s? So, or 20s, excuse me. They are looking for how many groups of 20s. So how many groups of 20s do they have in each individual stack of 20s? 4 is correct. There are 4 stacks of 20s. How can you find how many 10s there are in all? Well, we kind of discussed this a minute ago. We could divide the books into 10s and count up. Count by 10. We could divide that 20 into 10 plus 10 times 4. There's lots of different ways that we can do that. The next question, how many 10s are there? There are 8 10s. Explain how you can use skip counting to find the total number of books. Well, as we had done, you can skip count by 10s, counting each of those sets of books, and we found that to be 80. So this is just a visual on the back of your page, and I have my pages out so that I can follow along with you. It has some information about finding out more at the top. So if we can all take a look at that. It says multiplication is used to find a total when there are 2 or more groups with the same number in each group. You have learned some multiplication facts. These facts can help you multiply by 10s. The 4 stacks of 20 books can be shown using base 10 models, as you see on the screen here and you see on your paper. You can also show this with the multiplication expression 4 times 20. You can skip count equal groups of 10 or 20 to find the product. Okay, so we did both of these a minute ago, but this is kind of broken down where you can kind of see using your base 10 rods. So each rod, I keep pointing with my finger instead of my cursor, each rod has a 10 in it right here. There's a 10. So each group has 20 in it. And there's 4 groups of 20, 4 sets of 20. So we know that we can count these 10, 20, 30, 40, 50, 60, 70, 80, or by 20s, 20, 40, 60, 80. You can also count on by groups of 10s to multiply. So we know that we can do that, as we have discussed a little bit earlier. Count on by groups of 2 tens 4 times to find 4 times 20. Remember, 20 is simply 2 tens. 2 tens, 4 tens, 6 tens, 8 tens. That's how we can count on. 8 tens is also 80. These are just 2 other ways that we can look at solving this problem, especially when the numbers are not too large, but we can learn to work with the tens and make them work for us. But let's think about if we had the product 8 times 80. If we skip counted that, would it be really quick and easy? Probably not, unless you just happen to be able to count by 8s really, really well. So what we're going to do is we're going to show you some ways to maybe be able to do that can help you out and make it a little bit quicker. So you have a reflect question. Explain how you could find the product of 3 times 50. Let's just quickly talk about this. I do believe you will need to fill this in and turn it in when you're done. But let's just talk about what we could do here. So with the stacks of books, we had 4 stacks of 20. So this would be just the same. It would be like we had 3 stacks of 50 books. And if we had 3 stacks of 50, what were some ways that we could find the product? You're right. We can add up 53 times. And if we add up 53 times, we know if we have 50 cents and we have 50 cents and we put that together, that makes $1, right? So it's like 100. And if we have another 50 cents, it's $1.50. So it would be 150. We could also look at an array using 10 rods. Now, I don't know that I would really draw out 50 blocks because that's going to take you a really long time. But you could draw out 3 sets of 50 or 3 sets of 5 10 rods for each one, and then you could count up, skip count by tens. So those are 2 different ways that you could actually solve this problem. So I want you to pick what works best for you, what you found to use when we were going over this, and you can write an explanation for it here. Okay, we're going to keep going on then. So we're going to move on to the modeled and guided lesson or guided instruction. So here we have a question about baseball caps. So Sports Store orders 4 boxes of baseball caps. Each box has 40 caps. How many baseball caps are in all 4 boxes? So we're going to go real quick over the questions, and then I want you to get started working out the problem. What is the problem all about? Well, it's about a sports store, the number of boxes of baseball caps they have. And they are needing to know how many baseball caps they have in all, which is what we're trying to figure out. The information that is important is the number of completed boxes we have. Are those boxes full? Which you assume that since they tell us they don't tell us anything different. And we need to know how many's in each box. So how many boxes we have, how many's in each box. And we need to know what they're wanting from us. They're wanting us to help them know how many baseball caps they have in the 4 boxes. So again, take a couple of minutes and let's get started working on that problem. Remember that you can always pause this anytime you need a little bit extra time to work on a problem. But I'm going to go ahead and move on. So here are some great discussion starters that we can have. And if we were in the class, we would be using these to talk with each other about the mathematics. I knew this occurred or this was the answer, so I did this. I don't understand how. How did you get started? I disagree with this part because it's really important that we make sure we have those reasonings in there. So let's look at what the page gives us that you have in front of you. So just like before, we have represented here a box of caps, a box of caps, a box of caps, and a box of baseball caps. So we have 4 boxes. And in each 4 boxes, we can pretend that there are 4 rows of 10 in each one. That's why we have the 10 rods for each one. Okay. Now, we've discussed a couple of things of how we can do this yesterday, but let's see what's another way that we can do. If we have 40 caps in each box, excuse me, we have 4 groups of 4 10s, right? 4 groups of 4 10s. 1, 2, 3, 4. So we know that 4 times 4 is 16. So if we were to go through and count each individual 10 rod, we would have 16 10 rods. So that's as if we're saying 16 10s. So if we have 16 10s, class, what does that mean? If you said that it means that we have 160 baseball caps, you are correct. So let's look at, oh, I'm so sorry, I clicked it instead of slide it. Let's look at some ways that we can model this, as they say on the bottom of the page here. You can also use factors and grouping to multiply by 10s. So here's another way that we can do this. We can start with 4 times 40, but we may say, oh gosh, that's a lot. That's really kind of difficult for me to do. Well, we can break that 40 down. We can break it evenly to say it is 4 times 10, and that's how we're going to get 40. So now we have 4 times the product of 4 times 10. And I say the product of 4 times 10 because that's the parentheses. Okay. And that's kind of important just to be able to say that that's how we got 40. But we know because of different properties that those parentheses, when all we're doing is multiplying, can be moved around. Doesn't matter where the parentheses are when you're multiplying, it can just be moved around. Okay, so we could say 4 times 4 because we know how to do 4 times 4. We're learning that. And then we can multiply that 4 times 4 times 10. 4 times 4 is 16 because we can add up 4 times and get 16. And now we've got to not forget, we've got to multiply that by the 10. So if you multiply 16 times 10, you're going to get 160. This really comes in handy when you have like a problem that's like 364 and you just need to break it down a little bit. So we're going to look at our connect and reflect. If you will flip the page over to 95, we're going to connect all this together, okay? So it says, now you will solve the problems from the previous page by breaking apart a 2-digit number. Now, I know when I was learning to do this, it's real easy to make this a lot harder than what it is. We're just going to very simply break it down into 2 easier numbers. So below, we have 3 multiplication expressions from the previous page. But notice they said they are all equal. So they're all going to equal the same thing. We have 4 times 40, 4 times 4 times 10 and 16 times 10. You can break 16 into 10 plus another number. Write that number in the blank. So if we needed to break 16 apart, we can break it into 10 plus 6. That's right, guys. 10 plus 6. So in that point that you see on your page, you're going to put 6 down. So you're going to have 16 times 10 equals 10 plus 6 times 10. Then you can multiply both numbers in the parentheses in problem 2 by 10. Write the numbers in the blank. So we're just going to multiply it by 10. So 10 times 10 and 6 times 10. And now we're going to write the products. What are the answer of those two? So if we multiply 6 times 10, we're going to get how many? Let's count by tens 6 times. 10, 20, 30, 40, 50, 60. Exactly. We're going to get 6 times 10 is 60. Sometimes it's easy to get tongue-tied. Now, let's do the same thing with 10. You guys do it on your own and see if you can figure out by counting by tens what 10 times 10 is. If you got 100, you are correct. So now on number 4, we should have 60 plus 100. And now we simply add these products together to find the sum. And if we add 100 plus 60, we will get 160. So, excuse me, here we at number 6, they just give us a couple examples of what we might have been able to do when we multiplied the 4 times 80. I'm sorry, the 4 times 10, or even the 4 times 20. We could even do it with that too. And then the 4 times the 16 times 10. So we have the 8 times 10 and the 16 times 10. So what they're wanting you to do is to think about how they broke those down, and they're wanting you to explain it. So I'm gonna let you do that on your own. And then for 7 and 8, they have a try it. These two problems, and just try it on your own. Remember not to make a big deal out of it. Let's look at 7. We could break 7 down. We could do it a couple of different ways, actually. But let's kind of stick to it being sort of easy. We could say 6 times 10 and 10 times 10. Make sure I'm telling you right so I can write it down. It might be easier if I'm writing it down for you. And I told you wrong. That's what I thought I was, when I looked at it wrong. Which that just happens. Okay. Okay. It would simply look like this. Sorry, I forgot where I was. Okay, you can have 60 times 8. One of the ways you could break it down, and I hope you can see this okay, is 6 times 8 plus 8 times 10. Another way you could say, Oh, I lost my place. I'm so sorry. I wrote it. All right, this is another way we could do it. You could say 60 times 4 times 2, or it could be 60 times 4 plus 60 times 2. And that would also give you the answer. One of the great things to do with this, and sorry about that mix up, sometimes it's hard to think when you have other things going on in offices next to you, but a great thing to do with these is to try a couple of these different strategies. And if you struggle with the strategies, make sure you go back in these pages and take a look. Also, take a look on your Ready Math, your iReady, and there may be some stuff on there too that could help you. For homework, you have your practice and problem solving pages, and those pages are 103 through 106, and yes, 103 through 106. And so remember, those are your pages that are just a specific color. I believe you all's is red. And just go ahead and work on those and finish those. You can use your work that we did here today to help you. Get on your iReady, practice your individualized instruction plan that you have there. And we should all be good to go. And we'll see you tomorrow. Have a great afternoon. Bye-bye.